This is not an easy question, so let's actually make a table with the values of these equations on each of the 4 points. Here we have the 4 points on the top row. And now, each of the other rows will be one of the functions. Here's x plus y. We fill in the first row as follows. 0 plus 3 equals 3, 1 plus 2 equals 3, 2 plus 1 equals 3, and 3 plus 0 equals 3. So we see that x plus y, or the sum of the two coordinates, is 3 for each one of the points. For the second row, we see that their products are 0 times 3 equals 0 for the first one, 1 times 2 equals 2 for the second, 2 times 1 equals 2 for the third, and 3 times 0 equals 0 for the fourth. And for the last one, x squared, we see that 0 squared equals 0, 1 squared equals 1, 2 squared equals 4, and 3 squared equals 9. So let's think, which of these equations separates the green and the red points? We look at the sum x plus y, and that gives us 3 at every value, so it doesn't really separate them. If we look at x squared, so the first coordinate squared, we get 0 and 9 for the red values and 1 and 4 for the green values. This one also doesn't separate them since the red values are small and large, 0 and 9, and the green values are in between, 1 and 4. So we look at the product xy, and that gives us 0 for the red values and 2 for the green ones. So it seems that this one does the job, right? Since it's a function that gives us one value for the red points and another value from the green points, then it's a function that can tell red and green apart. So if you said xy, that is correct. That is the magic equation we'll use. So let's see, here we have our 4 points with coordinates x comma y and the product of their coordinates x times y. So for the red points x comma y, we have that the product xy is 0. And for the green points x comma y, we have that the product xy is 2. And what separates a 0 and a 2? Well, a 1. So the equation xy equals 1 will separate them. And what is xy equals 1? It's the same as y equals 1 over x. And the graph for y equals 1 over x is precisely this hyperbola over here. That is the curve we wanted. Okay, now let's look at what happens in 3 dimensions. And we recall that our magic equation which will separate the points is x times y. So we have our points with coordinates 0, 3, 1, 2, 2, 1, and 3, 0. And here we have a copy of the plane with an extra axis, the axis z, for height. So let's add this magic equation x times y to our coordinates. In other words, let's consider the map from 2 dimensions to 3 dimensions, which takes the point in the plane with coordinates x comma y to the point in space with coordinates x comma y comma x times y. This map sends the point 0, 3 to the point 0, 3, 0, the point 1, 2 to the point 1, 2, 2, the point 2, 1 to the point 2, 1, 2, and the point 3, 0 to the point 3, 0, 0. So in a different way, it still separates the points since it sends the green points up by 2 and it leaves the red points underneath. Now what could separate these points? Well, a plane could do it. This is the way to visualize the kernel trick in 3 dimensions.